I'd like to introduce you to the basic ideas of a simple regression. A major drawback of correlations is they have no units of measurement. There's no dimension associated with a correlation. So even though we know that the correlation between living area and sales price is 0.3, there's no way of saying, well, if the living area goes up by 10 square feet or 100 square feet, the price impact will be something related to 0.3. But with a regression, we can do that. So in order to do and obtain a regression, a simple regression, we can proceed in various ways. The first is, once we have done this scatter diagram, we click on any of the blue dots with the right mouse button and we say add a trend line. And here we have a couple of options, and I would, for the time being, just choose display equation on the chart. And what we get is this trend line here, as it's called, and in a simple regression we always only have one variable related to one dependent variable, so-called dependent variable. And what we get is two coefficients here. One coefficient, the so-called constant term, shows us where that regression line hits the vertical axis, so about 150. And 18.6 is the more interesting number here, which is the so-called slope. And this number now does have units of measurement that allow us to relate the square feet of the living area to the sales price. 18.6 simply means if the living area goes up by 1 unit, in this case square feet, the trend line, the regression line, goes up by 18.6 units, or dollars in this case. So if the living area would go up by 1,000 units, the price would go up by 18.6 times 1,000. Now notice that both of these numbers are based on all the data points in the sample, and both of them can be considered as showing us an average picture of that situation. Now, let me explain how this number 18.6 is obtained. It is based on the correlation coefficient in the following way: that we take the correlation coefficient, multiply it with the standard deviation of the sales price, and divide by the standard deviation of the living area. And this slope 18.6 now does have units of measurement, and it would be units of dollars per units of size, in this case square feet. Now this is the slope, and the so-called intercept or constant term, around 150,000 here, that is obtained by taking the mean of the sales price and subtract that slope times the mean of the square feet. Now what does that mean? This is the intercept. It is measured in the units of the sales price. So one way of thinking about it is, as I said before, 150,000 would be a price for a house with 0 size, which doesn't make a lot of sense. A more meaningful way of interpreting that number would be we use this intercept to make sure that if we consider a house which has average size, like 1600 in this case, we would expect that that regression line should give us a house with an average price, which is about 180 here. So this 150 is chosen in a way to make sure that the two means, the mean of the sales price and the mean of the living area, intersect exactly at the same point where the regression line goes through. So the regression line goes through the point where the two means of the two variables intersect. So that was a way of obtaining a regression, simple regression based on a chart. The other way would be based on the data analysis add-in. And for that purpose, we choose data analysis, we choose regression, we define the input range for y, and at that point we have to make up our mind what is the so-called dependent variable, usually called the y variable. Now we would like to say something about the sales price, so that's the y variable, and we're using the living area as a so-called x variable or explanatory variable. It would be the one which we consider as determining the price, at least one of the determinant factors. Later on in another video I will cover several x variables. Since we've included the labels of the names of those variables in the first row, we check the labels, and as the output range, as usual, I'll put that right into this sheet here. And here is a summary table. And first thing is we get the same numbers that we've computed before, but this time based on this data analysis add-in regression, other than those numbers here, which were depending on the individual functions. Those values that we see here won't change if anything in the data changes. Now, in order to show you the impact of changes in the data, let's see what happens if we consider this number here as a typo, and I'll have an explanation for it in another video. It's not a typo. We see that the scatter of point changes and the slope changes, and accordingly these two numbers change. So what we would now say would be, given the situation from this sample of data, an increase in the living area by 1 unit on average is associated with an increase in the prices of houses by $100.